I should do like Fabrice does. So I understand that we have the evening and the night for us. Good news. At least, well, I'm not sure it's completely good news. So good afternoon. As you know, in 2014, we are celebrating the 100 years anniversary of the first commercial flight. It was a 23 minutes flight over Tampa Bay in Florida, and there was one pilot and one passenger who accepted to pay the equivalent of $10,000 for this inaugural commercial flight. The challenge at that time was, well, one was to have a passenger paying, accepting to pay. Nowadays, the equivalent of the population of New York, about 9 million people, are flying every day somewhere in the world. So the issue is no more to get passengers, but there is still a lot of challenges in front of us. Challenges such as the development of emerging economies, which means new needs, but also new players. Environmental concerns, which is a very important topic for our industry. You know that we are regularly under scrutiny on that, and we are doing a lot of efforts in the domain of energy. Security. I guess many of you traveled to Toulouse in a flight, and I guess you all suffered from the checkpoints, security checkpoints at the airports. This is becoming more and more an issue, and at the same time, obviously, there is no compromise possible on security. Scarcity of resources is another challenge. You think immediately about fuel, but we also have some issues with some materials that we're using, either in structures or in electronics. And obviously traffic growth. Traffic growth which may also be limited by some elements like the air traffic control, the air traffic management, but also the availability of airports close to the cities. In front of those challenges, there are opportunities, there are game changers appearing, and the first one I would like to address is 3D printing. There will be a specific presentation given later on by Curtis Carson on what we do in that domain. 3D printing, you know, this technology is a really wonderful one because it's allowing us to probably optimize the design of parts as ever before with regard to weight, because you just need to put the material where you need it, and it allows things like what is represented here on the screen, bionic design, really having material where you need it. It's also a green technology because it's using less material. We can reduce up to 95%, yes, the proportion of material waste with this technology. And last but not least, it's a technology that is allowing new models, for instance, for spare parts. It's about printing the parts you need, the spare parts you need, when you need them and where you need them. So 3D printing, but we will come back on that. Big data analytics is another revolution that is impacting us directly. Every flight is representing terabytes of data, and the correct exploitation of the data coming from the aircraft can give the opportunity of further optimizing the maintenance of the aircraft, or can also globally lead to optimization of the use of the aircraft to address fuel-burn reductions. Automation and robotics, I will not say a lot about that because there also we will have a specific presentation on future of the factory, and you've seen probably this robot on the left on my left, on your right, the stage. So Michel Roboham, who will just talk after me, will come back on all those elements that are contributing to the factory of the future. It's also about paperless. And the next topic, by the way, has also connected object, has also to do with the factory of the future. It may be a way to track, monitor the tooling in the shops, or to monitor the parts to be assembled. And last but not least, we had the presentation just before of Didier Evra on the 350 materials, and obviously when we think about materials, we think about composite carbon fiber reinforced plastics, which is obviously a revolution in the industry, but we are also working on new light alloys, light aluminum alloys, combined, by the way, with some of the processes such as 3D printing. But now I would like to guide you through a few cool stories about some of the challenges we are tackling. Last year, in the same forum at the 2013 Innovation Days, I was introducing to some of you the Back2Go concept. And one of you who were there last year probably remember that Back2Go is addressing a critical issue both for passengers and for airlines, which is the loss of luggage. There are 2.5 million bags lost every year, and this costs to airlines $2.6 billion US. So it's a big impact. So we are working together with Test Systems and Remover on a concept that will be soon tested with the first airline. You remember probably last year I was addressing the fact that technically it was okay, but we were still thinking about what should be the business model for such a concept, and now we are close to there. For me it's good because it shows also that innovation is not only addressing the platforms, but it's also addressing things which are around the platform, which are contributing to the experience of the passengers. Environment is also an important topic to us. I said it. Obviously, Airbus is committed to the targets of the Flight Path 2050 of the European Commission. So this is 75% CO2 emissions reduction, 90% reduction of NOx, and 65% reduction of noise. More concretely, in May, we had the longest flight with KLM on an A330-200 with biofuel from Schiphol in Netherlands to the Dutch Caribbean island Aruba. So we are permanently continuing to work on those topics, but I think that Champion will also address that tomorrow. Another story in the domain of environment is what we do in the domain of carbon fibers recycling. So obviously, as we are using more and more of them, we need to think about how to recycle those fibers. And first, the wasted fibers coming from our industrial activities. So we created a specific advisory board on that within Airbus, which is promoting, encouraging, pushing and coordinating actions in that domain with a target of reducing the amount of waste which will not be used. So the target is to recycle 95% of the wasted fibers in the shops between 2020 and 2025. And the ultimate target would be to reach the same figure, 95% of recyclability on the aircraft once it has developed its life. Security. For security, I have two nice stories, both being related to collaborations we have with small companies. The first one is about on-ground aircraft security. You know or you don't know, and if you don't know, I will tell you. There are seals like this one. I don't know if you can see it on with the camera. Anyway, we'll show you after. Seals which are put on the doors of aircraft, so all the doors, so it's about 30 doors on an A320, 50 doors on an A380 every night, to make sure that so it's passenger doors, cargo doors, avionics, and so on, to make sure that nobody is having an action on the aircraft while it is stored. This is representing for the operator about 1 hour of work in the evening for putting the seals and writing on a notebook the serial numbers of the different seals, and another hour on the day after to remove the seals and check that everything is okay. So we have developed with the small company from this region in Toulouse called the Sigfox, a solution which is a remote wireless electronics system to check, to monitor that the doors remain closed and are not attacked during the night. And it's based on low-cost radio communication technology, which is developed by this small company Sigfox. Another example is coming from Halifax in Canada. We signed on the 4th of June last week an agreement with this small company called Lambda Guard, an agreement to develop a solution to protect windscreens of our aircraft against laser incidents. The US Federal Aviation Administration reported that in 2013 there were close to 4,000 of those laser strike incidents. Is it on purpose or is it accidental? We don't know, but in total it's 3,960, something like that, incidents. So it's very important to find a solution. So these two domains show that we are not, again, focusing only on the platform, but we are also thinking about how the platforms are operated, what may be an issue for the airlines, and obviously, as an industrial leader, we need to tackle all these aspects around the aircraft. Last example I would like to give concerns traffic growth, which is good news because we are selling aircraft, which is also an issue because then there is a certain congestion. One way to answer this is to propose to our customers larger, cost-effective aircraft. Another way is what we do with our subsidiary ProSky to find solutions to improve the air traffic management and the air traffic control. But I have a funny story there. It's what we did, what we developed based on the competencies we have in the domain of electromagnetic waves compatibility. It's stealthy panels. You know that a key point in the traffic growth is to keep airports close to the cities, and airports close to the cities are confined with terrains available. More and more there are requests to build things closer to the runways, which is creating interferences with ILS. So this is a solution that we developed, and recently we were out at the Cahors airport close to Toulouse to test those panels, and I would like now to leave the floor to our colleagues who will give more detailed explanation about it. So there is a small movie that will give you more details on that.
Most major airports in the world are equipped with a navigation system that allows aeroplanes to land in low visibility conditions. This system, known as the Instrument Landing System, or ILS, but it does have one shortcoming. If we wish to construct buildings close to runways, the facade of the buildings can act as large mirrors reflecting the ILS signal across the runway and falsifying the heading displayed in the cockpit. The aircraft can even exit the runway. In practice, to avoid this, planning permission is only granted for buildings close to runways if it can be clearly demonstrated that the building does not perturb the instrument landing system. If we would like to build close to a runway, we need to find a means of preventing buildings from reflecting radio waves. We need to create stealthy buildings. 2 years ago, we proposed a solution that allowed a hangar to be built at only 380 meters from the runway of Toulouse International Airport. Airbus immediately realized that there was a great potential for using this technology to develop airports worldwide. The technology was very bulky and heavy, consisting of crenellations made of metal 70 centimeters in depth. Since then, we have solved these problems, and today I'll be presenting a thin, lightweight solution that allows any type of building to be constructed close to runways. This aerodrome is equipped with an ILS localizer antenna operated by French Civil Aviation Authority, the DGAC, making it the perfect location to perform tests. Behind me is a test facade which measures 30 meters in width and 5 meters in height. What we actually see is the plastic rain protection, which is red and white to make it very visible to the other users of the aerodrome. What is more interesting is what's inside, behind the rain protection. In fact, there are several blocks, much like this one that I have beside me, that consist of folded aluminium panels with very precise dimensions so that they behave as an electronic resonator circuit. But rather than being powered by batteries, this resonator circuit is powered by the incoming radio wave from the ILS system, which interacts with it, and rather than being reflected across the runway, is redirected to a zone well away from the runway so that it does not perturb incoming aircraft. So with this thin, lightweight solution, we can build any kind of building close to runways. We can even apply it to existing buildings if they present too much perturbations. Members of the DGAC measure the perturbation from the facade on the runway center line using their specially equipped vehicle. We would like to demonstrate this facade in all weather conditions, and considering it's a dry, sunny day today, we've invited members of the Cahors Fire Brigade to come along and direct jets of water towards the facade to simulate a very rainy day.
The top 150 airports in the world could be interesting in this technology, and most of them are surrounded by cities and have no extra rooms to expand. Our solution offers them the possibility to construct buildings closer to the runway, and when we consider the price for 1 square meter in London City airports, for example, we can imagine that this solution could be very, very interesting for all airport stakeholders.
Now, ladies and gentlemen, all those innovations do not happen by chance. Innovation is about change, and I think that what Didier presented just before about Airline One is a good illustration. Innovation is not only about new technologies, it's also about new ways of working to increase the speed of development of new solutions. And this is what we do, we embrace change. I was appointed, as it was said, a year ago by Fabrice Brégier, and I gathered around me a small team of talented people aiming at increasing the agility and the speed of our innovation process throughout Airbus. And this was done with the support of a network of what we call innovation catalysts, which are spread over the complete organization, and you see some of them on the picture. We have developed specific spaces to help people, to allow people to be more creative, more innovative, to think differently, to address things in a different way, not being too much focused on technical solutions, but also addressing the business model around the technical solution. And we have now about 50 spaces like that are used for idea generation, for rapid prototyping of our solutions, sometimes using 3D printing, by the way, or developing new business models. And the reason for doing that is to develop more rapidly value for our customers. One example I like very much is the one we developed with Mach 9, which is about rapidly testing and adopting technologies which are coming from the consumer's good world, and in that case is a tablet. You see how it was before, 10 to 20 kilograms of papers that the pilot had to take on board, and now just a tablet. You see the smile on the face of the pilot, and we understand immediately the value for it. And 10 to 20 kilograms for the pilot, the same for the co-pilot, is not something which is negligible. But all this, we cannot do it alone, and we do not want to do it alone, by the way. So innovation is also about collaboration, co-innovation with our ecosystem. All the examples I gave are examples that are performed in collaboration with people of our ecosystem or companies of our ecosystem. So in the case of Back2Go, it's a telecommunication operator, T-System, it's a bag manufacturer, it's Bimova. In the case of the biofuel test, obviously we work with the airlines. In the case of the laser protection, you see on this picture George Palikaras, who is the CEO of this small company in Halifax, Canada. So it's with SMEs and startups, I mentioned as well Sigfox, and it's with airports. But obviously an important point is to get our own people collaborating between themselves, avoiding to work in silos, engaging our employees, and we are using ID generation campaigns also to bring them together on things which are important for the group. And you see an example of a campaign which was recently launched in May with a termination in a few days on 3D printing. The target is to identify applications which are relevant for this new technology. So engaging our employees is something which is absolutely important. So what you heard today, this morning and this afternoon was about the programs, the development of programs. I gave examples of what we do also today to improve the products and services around the products. But innovation is also about the future. So tomorrow you will have a presentation by Charles Champion about important initiatives that we are part of, like CISA in the domain of air traffic management or Clean Sky. But I would like to spend more time now with Michel Oboram, who will come on stage, on how Airbus is manufacturing the future. Everything we do in the shops is very important for the quality of our products, for the performance of our products, and also for the performance of the company. So, Michel, it's your turn.
Good afternoon, ladies and gentlemen. So I'm very pleased to be with you to talk for a few minutes about the Future Factory project. If you are expecting from me that I will only talk about robots, automation, automatic system, you will be certainly very disappointed. Because the major benefits we will get in the future in our factories will not be coming only from robots and automation, but a lot about people, simplification, competencies, and supporting on a daily business the job of our blue collars which are manufacturing our aircraft. This Future Factory project has mainly started last year together with the change in the product policy we have, let's say, implemented recently in Airbus. Over the last 20 years, we have been going through one new development program after another. Okay, starting a long time ago with the 300, the 320, and so on, up to the 350. And this was for us, each time we implement or develop a new program, to implement a new industrial system to support the manufacturing of this new project. And installing a new industrial system, we took the chance, of course, to implement the latest technologies, automatic system, and so on. In the coming 10 to 15 years, we will have no more major development programs, but derivatives. Derivatives means slight modification or improvement on the aircraft, which will not touch, I would say, the full industrial system, which will address some area of the industrial system. Example, the pylons, which are the ones which are attaching the engine to the wings. And making just an improvement on the pylon will not change dramatically the recurring cost of the single leg, because we are just touching one component out of the full system. So it was clearly important for us to continue to improve our efficiency of the industrial system by introducing technologies, but on a very different way compared to the past. The past, as I said, was every single new program we introduce totally new technologies. This time we have to introduce technologies on running programs, which is a bit more difficult. And to be sure, because we have already an existing system, that the improvement we bring has a real return on investment. So this is exactly the purpose of the Future Factory. So I suppose I have to push the button. Yes. So, civil aircraft is clearly evolving today and continue to grow. And if we consider single aisle, nobody would have thought 10 years ago or 15 years ago that we could reach rate up to 50 per month. This is something where our industrial system was not prepared to. And on top, having this volume of activity is bringing us also possibility to make much more automation and much more, I would say, efficiency improvement, and allow also to make better investment, to have a better return on investment. Ramp up is clearly something we have to support, and having the ramp up, it's clearly on help for us to think differently our industrial system, and we are doing currently for our single aisle major step change in our industrial system, like in Breton, like in Hamburg, like in Nantes, to allow to improve the efficiency together with the capability to produce more. Quality clearly is the number one criteria for every single improvement we are doing in the shop floor. Quality, time, and cost in this order are clearly the main driver for every improvement we are bringing on the industrial system. Flexibility also is clearly something important, because as we go for an incremental improvement of our aircraft, taking the single aisle, going to the single aisle Neo, tomorrow the Neo Plus, and potentially the Neo Plus Plus, means we have to have an industrial system able to cope with the change we introduce. And if we don't have the flexibility, it means we'll have to rebuild our industrial system each time we do modification, which is clearly not cost efficient. Emerging competitor, of course, is also pushing us to continue to improve our productivity, to reduce further our recurring cost, because at the end of the day, the market will fix the price of the aircraft, and it's already fixing the price of the aircraft. And if we want to continue to generate benefits, we have to continue to reduce our recurring costs. And of course, customer satisfaction means we have to bring first time right, the quality, and the on-time delivery to ensure our customer satisfaction. If you go to the next, yes. Future Factory is a major project which is in fact having two ambitions. First ambition is to be ready the day a new program will come, and one day a new program will come, not tomorrow I would say, but certainly the day after tomorrow. So in 10 to 15 years, when we launch a new program, we'll have to be ready with industrial systems which are able to achieve the objective we have set for us and which are described in this slide. But in the meantime, we'll not wait and doing nothing, waiting to get the minus 50% on recurring costs. We implement through the Future Factory project a very incremental approach where we introduce step by step technologies, bricks, small improvements which will deal at the end to bring the 50%. So these are the four first objectives that we have set for ourselves, to get clearly an RC and a lead time prediction about 50% at the horizon of a new program. And in the meantime, every year we are bringing to the shop floor improvements that I will describe later, which will bring, on a pure incremental approach, improvements in the system. Right first time and on-time industrial system is also something which is very important. We have today, like in every industry, pre-production line for Future Factory, which will allow clearly to remove and to significantly reduce at least all the reworks we could have by setting a line with a new line. Zero defect and industrial flexibility, as I was mentioning before, is clearly also a big area of concern, where we want to accelerate technology to really mature them much more, and really to be ready the day we implement them in the shop floor. This will bring certainly concession reduction and non-recurring cost improvement in the number which I indicated there. The last three pillars of this Future Factory, one is around human being. You will see in most of the technology we are developing, the blue collar are around all these improvements. Because our industry requires, and this is clearly certainly one of the specificity of this industry, highly skilled people. And there is plenty of area in the shop floor where it's impossible to replace the blue collar and the knowledge and the know-how they have to do the job. So we are pushing a lot of technology not to replace the blue collar, which is not at all the purpose, but to help them to support and to facilitate their work. And this is clearly one of the key pillars of this Future Factory project. You will see around that a lot of initiatives, like the smart tool, like exoskeleton and so on, like paperless also, which are there clearly to support the guys, to ensure they will deliver better quality, and of course, improving the efficiency. Ergonomics, having a more friendly environment, and intelligent technology, smart technology, clearly to support the blue collar. This will allow, for sure, to reduce absenteeism, but also to clearly improve the efficiency. Integrated system, you will see from some examples that sometimes simplifying a system, focusing on the logistic, being sure that every single part, tool and so on is very close to the blue collar to ensure he has not to work a lot to make the job, is improving the efficiency significantly. And logistics is one of the drivers. Eco-efficiency also is to reduce waste, and all the technology we are developing should be also supporting this type of approach. Short minute.
Drucker im Prinzip.
I hope you like the movie. It looks to be quite futuristic, but it's not. All the bricks of technology you have seen there, either they are existing, just the crawler robot, for example, today they are working in Hamburg to join the fuselage in Hamburg for 380. So it's clearly something existing. The laser positioning has been developed for S350 for all the section assembly, and it's in place, it's working. And you have most of the things you have seen there, either they are existing or we have a project in terms of R&D for development. All this technology clearly will be fully implemented in less than 10 years. So even if it looks quite futuristic, it is more than a realistic view of what could be tomorrow our industrial system. Now, what is also important, you have seen in this movie also a lot of people still working in the assembly of the component, and most of the technology which are there to support and to help the blue collar to achieve job. Whether we have this smart tooling, which are helping them to get the proper data when they need to make an operation. The paperless also, which is clearly supporting the guys, whether we have a mixed reality or tablet or whatever, I would say, equipment to do the job. All these systems which are able to carry the loads that the blue collar is not longer to carry and helping for positioning, means most of the technology are there and are there around the blue collar, except I would say for some area like painting, where clearly robots can do that quite better than people. Rifting also, which is not, I would say, a task which is quite easy and quite nice to do. But for everything else which is bringing value to the product, clearly human being is the better, let's say, one to ensure that the job is done on quality, on time and on cost. For doing that, I would say we have a network of people. I mean, because everything at the end, when you're talking technology and improvement in the system, is clearly because people have ideas and are able to push the ideas up to the implementation and to make them alive. Okay? And for that, we have an R&D, Research and Technology Expert Network, which are located in all our plants. We have 11 plants in Europe which are working, plus one in China, 2 in China with the FAL and Beijing. And we have also the FAL now soon in Alabama, which will also deliver aircraft. And all these people are working together transnationally to share their knowledge, their technology development, to be sure that as soon as one technology is available in one plant, it's distributed everywhere for the full efficiency of the people. As I said, I would say Future Factory is not something new in the sense of we got a smart idea last year, this is time to implement automation in Airbus. This is not the case at all. As I told you, in every single development program we had in the past, starting more than 20 years ago, we have implemented automation in all our plants. Whether you go for single L, 380, A400M, and 350, which is certainly the more advanced one in terms of industrial system, we have been going through automation everywhere, as long, again, as it's bringing value to the business, and we are getting, I would say, better performance than the blue collar, which are doing the job currently. So we have, of course, a lot of automation in part manufacturing. Part manufacturing, whether it's composite or metallic, is more or less fully automated today. Okay? And assembly, wherever we have business case, we have implemented automatic system for drilling, for fastening, for whatever, I would say, type of operation you want, as long, again, we have a return on investment and the quality clearly is respected. So now Future Factory will bring further technology to be sure that we are continuously improving the efficiency of our system. Like, for example, of course, automation using robots, like the one you have besides me on my left and your right, as Jan said. This is a cobot, means a cobot working together with the blue collar. So it's not again to replace the blue collar, it's to support the blue collar in their daily operation. Like again you have seen in the movie, doing things that the guy can't access, or which are quite heavy to carry, but not again to replace. And this cobot should be also flexible enough to do more or less operations inside of an aircraft, which is not, as like in other industry, an easy area to work. We have this flex track you have on the top right, which is in fact a very simple system to allow drilling. It's existing, it's a deployment on A350, and we continue to deploy that on other, I would say, program, wherever, again, we have a business case. So we have standard robots, of course, which are deployed to do drilling, to do positioning, to do fastening, to do painting, to do sealant application. whatever I would say is the operation we have to do. And we are continuously, I would say, looking for further technology which could come and that we can implement to bring efficiency in the shop floor. On top, to continuously also support our blue collar, we are investing in whatever capability enhancement we can provide, whether it is through exoskeleton, through paperless, through 3D model, all type, I would say, of equipment which are there clearly to remove, for example, paper, to simplify and to bring information to the operator to facilitate his job, that he has not to look for, say, for the information he needs to perform a job, but that all the information are there, consistent through the IT system, which is also key to ensure consistency between engineering data and what is used in the shop floor to perform the job, and to be sure we are bringing clearly robustness into the system. So around, again, future factory is not something which is new, it's a different approach with different ambition, with a short-term view also, but also a long-term view. And at the end, everything has been built around the blue collar to facilitate their job and to be sure that tomorrow and today we are getting more efficiency and better quality of our products. Now I will hand over to Curtis, which will detail a bit more something which has been already mentioned at least 3 times or 4 times during the day. So it means a very promising technology which is called 3D printing or ALM, additive layer manufacturing. Curtis, the floor is yours.
He's a little bit bigger than he is. Well, good afternoon, everybody. I'll try and be as quick as possible, as I seem to have the last slot of the day, but hopefully the 3D printing topic would be of interest to you. Just one little question before we dive in with regards to 3D printing. I'm just curious, in the room, how many people here are familiar with 3D printing technology? It's a good number, I would say. I imagine some of you might even have written about it. So let's jump in. So, the potential. Actually, it's kind of funny, I have this slide here. I wasn't expecting them to park the 3D behind for the presentation, but it seems to be there. There is a significant amount of potential today when we talk about 3D printing. We talk about weight. If we're reducing the weight of the parts, you've seen in Jan's presentation one of the bionic shapes that we can produce coming from a printer. With that reduction of weight, we can reduce the amount of material we use. The amount of material we use, it reduces the amount of cost we can spend if we're talking about titanium. It also means we can reduce the logistics and shipping of materials between sites to do fabrication of parts or components. We have potential with complex assemblies. I think it was presented earlier this afternoon. There was an A400M part where you can take a multitude of components and parts that you would have had to assemble in complex or multiple step process. You can print this in one shot. You can do prototyping. There is a lot of potential. But what do we need to do? And I mean, this is more, I would say, the interesting part. How and what can we do to tap into that potential? We, here at Airbus today, what we've done to try and figure out how to unlock this potential inside the community, our first step was we've taken the people, I would say, inside the organization we have today, the experts, the specialists, the people working in R&T, the people that start to have contact with the technology through procurement, and we've created a platform. And what's interesting about the platform is the multitude of the functions inside the business that we bring together. We bring everyone together in one spot. We then turn our attention to the technology and the capability we have today to figure out, and like in the video, what you saw is what this organization is starting to do is scan our aircraft, like the one we have behind us here, and try to identify all the potential opportunities. We could take the technology that's available today and see what this could be. We have the support of our executives, like Yann, like Michel, like other executives inside Airbus. So we have the attention, we have the support. We started the screening exercise to see what the scope and the magnitude or volume of opportunity could be. And then what we embark on with regards to this is, depending on the domain, because we're not talking just about flying parts, we have examples where tooling, things you might never have thought of in the past, are now possible due to the capability the technology brings. We start to take these opportunities and run through the different steps we need to inside our business, whether it be qualification, to ensure the material works as it says it's supposed to work, the machine prints as it's supposed to print in terms of the repeatability, the methods and tools. It's not so obvious when you start into a technology that offers so much potential as 3D printing that, like if you take a bionic part, if anyone's working in the standard business today with CATIA, it's not so well suited to making a bionic shape. So you have to have different methods and tools. You have to have different skills and competencies. The way you would have designed a part for like an A380 or an A320 using standard metal machining methodologies or forging or whatever else, it's not the same. So we need to build up these competencies. We need to make the link to our research and development. So what we're plugging into the business today, we have a link with the steps that we want to make going forward in the future. And all of this comes together, like was mentioned earlier also by Yann, it comes together with the people. And we've started with this, I would say, core group of people focusing on the technology as a package and as a whole. So we have a plan, we have a direction we want to go, we have a strategy. In terms of examples of applications, we start to investigate and we start to have come to the surface in this domain. Like mentioning earlier, we have tooling. The tooling application here is just a simple ergonomic means on which the operator and the blue-collar worker we have in the aircraft is able to take a multiple set of pipes, fix them in advance out of the aircraft away from the congestion that might be in the area, pre-position them, and then quickly walk into the aircraft to put them in their final position. This was not so simple to do in the past. You would have had to have figured out the shape, the form, you would have had to ask to a supplier to get the parts or components in whatever shape and size, test how they hold the pipes together, and so forth. And something like this, having the capability in-house, is something that you can quickly do between an operator, a manufacturing engineer, and within hours you can have a first prototype testing near the aircraft, how you can enable the simplification on the installation. Prototyping for sure. I mean, 3D printing is not something that's just started last year. It's been around for a number of years. It allows us to do different aspects in terms of checking fit, form, function, with physical components and parts coming from digital definition. Do the fasteners go together correctly? Do we have the proper clearances? It offers, I would say, rapid access to different components. If you take even just something like this, I mean, we've seen a lot of people in building our aircraft. This is just a small tooling guide that we can use in the drilling operations that we have in the aircraft. We have thousands of fasteners, thousands of components, and something like this, we're able to save a significant amount of money and have the agility on how quickly we can adapt a guide or an aid for a guy to do the job properly and correctly from the first time. Flying parts for sure. I mean, the ultimate goal, I would say, in our business is the potential we can have in terms of applying flying parts. We have one of the metal parts here, you can see in the picture, it's also over on the desk on the side near the robot. We're able to reduce the weight of the part between the upper part and the lower part by 30 to 35%, which, when you start to add up parts and components like this for a large aircraft like an A380 or an A350, can start to be quite significant. The other part we have is a plastic component. I have to say it's not so sexy to look at in terms of the shape or form, but what's interesting about the application here is between the upper pitcher and the lower pitcher, the difference in cost is a savings of over 70%. We have a reduction of almost 50% in terms of weight, and we're able to do it in a lead time that is significantly faster than how we would have had the original part produced. Another simple example like that is this little plastic piece here again. Like I said, not so sexy, except for maybe the business people in the business when they see the figures we're giving back in terms of money. These are flying on A350 for flight tests today. We have over 70% savings in terms of the cost for a simple little plastic part like this to go into our flight test installation on the aircraft, and over 70% lead time in terms of providing it to the aircraft. Spare parts is another avenue that also has a significant benefit that we've started to uncover, is that in the case here, and I imagine you might hear about it tomorrow a little bit with our services people, the part here was produced due to the fact that the original part for the A300, the supplier went out of business, the tools to make the part were not existent anymore, the drawings we still had, but there was no standard way to produce the part anymore. And the teams working in a collaborative mode across the business were able to come up with a simple and fast way to take the printing technology, print the part, certify that the part meets the requirements that it needs to meet, and bring it to the aircraft. And one of the other things I would say in terms of what we're doing today with regards to this activity is we're finding, like I said earlier, the ways to qualify this and insert this into our business. To finish, to be very, very short with regards to this is what we're doing concretely today to materialize it in our business. It doesn't mean as engineers, when we talk about the future factory or the future aircraft, that there's not dreaming, and our engineers are very, very creative when it comes up to what the future will look like. There's nothing to say that the future tomorrow with a technology like printing, in the years to come, not the next day after the next, because it's not just the push-button technology that you can immediately start to do such grand things. But it's only if we're able to, I would say, commit ourselves to the journey that we've started inside the business that we're actually able to see if something like this is possible. And I promised to be quick. I think I was. Yes, we're good.